In 2023, ChatGPT tricks and prompt videos have already flooded your feeds. We haven't seen such a rush since the iPhone or even the rise of the internet. But what's missing in most discussions is the key to real success, integrating it into broader ecosystems. In this video, we'll be discussing a prerequisite. Master the formatting and parsing structured completions. Stay ahead of the competition by learning how to combine ChatGPT with other technologies, while others are simply exploring the novelty of the funny prompts. Hi, I'm George from CRANQ. Today we will be discussing how to ask OpenAI, generate well-formed responses, and how to build applications on top of it. If you enjoy the video, please like and subscribe to our channel. We will be providing more details and several examples in future videos. The first type of tasks one tries ChatGPT with are usually one of the classic applications of a language model, like you give it a 2-page memo text and ask a few-line summary. Some variant is to rely on its knowledge when we query about documents it has seen during pre-training. Like now, I'm asking about an ancient Greek drama. And of course, we can ask it to respond in various styles or languages, including German, which I requested here. It can even take on the role of many language-understanding characters using specific prompts. What is common in these scenarios is that the model is used in an interactive way. It can understand virtually anything you say without requiring to learn any specific syntax. Sometimes this is all that we want. A lot of useful applications can be built around free-form responses. They can be treated as opaque strings and transmitted across different devices and services without requiring in-depth understanding. Chatbots, personal assistants, and translator apps serve as excellent illustrations of this concept. Even in simple applications, CRANQ can be a valuable resource thanks to its diverse range of connectors for gathering and returning user messages via mobile phones or web services, converting between text and speech, and more. The key takeaway is that this simple scenario illustrates a common pattern that we will continue to refine. We receive the user's input from various sources, prepare a prompt that describes the desired task as accurately as possible, and then combine the prompt with the user's request. As you can see, we have begun with a straightforward prompt in this example. Now, the returned completion is simply extracted from OpenAI's response structure. However, in more sophisticated applications, you may want to apply additional logic for processing and sanitization for both the input and output. Now we are ready to move to the next level. The text generated by OpenAI is often a complex response that carries a lot of information, context, and structure that we are eager to use in further operations. To make the most out of the generated text, it's important to ensure that it can be easily understood and parsed. However, achieving this goal can sometimes be challenging, as we may encounter difficulties in extracting the relevant information from the text. Without precise instructions, the returned format can be wildly different. I asked ChatGPT what we need to do if we want to algorithmically process the response further. And here's the answer. One of the biggest challenges in using GPT for algorithmic processing is that its responses are not structured data and may contain irrelevant information, misspellings, or inaccuracies. To overcome this challenge, we need to create prompts that result in a predictable output format as much as possible. And we also need to parse, clean, sort, and possibly verify the results. Fortunately, CRANQ is designed to handle all of these tasks. As a demonstration, let's start with a query that we think doesn't require much preparation. Suppose we want to assist students in easily identifying the individuals responsible for various inventions, along with the year they were discovered. The first attempt immediately reveals that unconstrained prompts can generate an overwhelming amount of noise, confirming ChatGPT's concerns about its output format. Merely requesting a name falls far short of what is required to develop a parser. It is evident that this approach is unsuitable for the task at hand. Let's try to reduce the noise in the response. However, for actual prompts, we need to be more specific. Try with larger groups, see how comma and is used in combination sometimes, and consider the possibility of separators in names or groups. As a rule of thumb, the more effort you put into designing a high-quality prompt, the less effort you will need to invest in parsing the results, and vice versa. Poorly designed prompts can result in output that is difficult or impossible to parse. To save time, we won't demonstrate how injecting the invention's date into the response incorrectly can ruin the formatted output. However, we encourage you to experiment with it. Now let's continue in OpenAI's playground. Keep in mind that while the ChatGPT interface is convenient, it uses a somewhat different model than the ones you can call from the API. We've already prepared a prompt here that displays some elements of the pattern we'll always follow. In addition to extending the previous example by requesting a date and making a few modifications, we've structured the prompt according to the nodes layout we previously seen in CRANQ. The first part of the prompt provides all the necessary format requests and boilerplate language, so the user doesn't have to come up with them. The final line of the prompt is where the user input takes place. Also notice that we not only explain how the response should be formatted, but also give an example with some made-up data. This is the usually recommended way to create prompts. Give both a description as specific as possible and also provide one or more examples. Actually, if you try this without the example, you will see that sometimes it fails to meet the requested format. Just for giving an outlook, if you need other specific formatting, it is likely that you can craft a prompt for that too. In this case, we required the data line start with a double right arrow and the year must be in double parentheses too. Before we proceed, let's take a quick look at an example of how a simple parser can be written in CRANQ. We start by fetching the text part that we're currently interested in from the big API response. After that, we perform some quick cleaning. Sometimes it can be challenging to convince OpenAI not to insert empty lines. Since we only expect a single real payload line, we can take it as the first string from an array. Finally, we split the string using a regex splitter node. Of course, in a real application, we would perform additional sanity checks and error handling. In dealing with search responses, it's not always possible to anticipate or control all variations. Therefore, follow the principle of everything is allowed that is not prohibited. Keep in mind that even with explicit requests, some responses may not meet those criteria, so flexibility may be necessary. To save time, let's skip launching all those queries and instead refer to my original notes from when I first experimented with ChatGPT. Although not exhaustive, we can observe several patterns. Even for simple questions, responses can contain different number of pieces of information. For the more complex questions about bands and singers, responses can vary in the number of items, use of bullet points or numbers, labeling of data, and capitalization or omission of labels. There's complete freedom in using separators or parentheses to organize components. Do we really need to be so careful? After all, GPT is known to understand some standard formatting rules by default, such as comma-separated values format. Let's give it some advantage and let it choose what data to return in that format. Let's take a moment to make your prediction. Do you think it will work fine? Unfortunately, it turns out that OpenAI did understand the required high-level format, but it didn't realize that the number formatting, such as digit group separators, could interfere with the table structure. It's important to remember that GPT is ultimately a language model. Let's see if the same thing happens with the DaVinci 3 model when we ask it to return the name GDP and population this time. Once again, the model does not recognize that commas will disrupt the table. It is easy to fix the highest level structure, but we must explicitly ask for the values to be enclosed in quotes. However, even though we've solved the table structure problem, some of the values in it may have a quasi-numeric format based on whatever values the model has seen in the training document. We will address this issue in the next chapter. Our next option is JSON. It presents a strict, well-defined structure that can reduce the amount of work required on the parsing side, and CRANQ has built-in support for parsing it. However, the following examples will demonstrate the importance of being specific about the exact structure and content of the response. Let's consider small economies as an example again. Without specific instructions, the JSON response can take any valid form. This may lead to unexpected results, such as a nested dictionary where top-level keys are used as array-like indices. Although this is a valid JSON format, parsers we wrote for reasonable layouts may be confused if occasionally get results like this. To obtain more predictable results, we can extend the prompt by providing specific criteria. Firstly, we can request OpenAI to use an array instead of attempting to create top-level keys for each item. Additionally, we can specify the exact names of the keys to use, which may differ from the free-form description of the data. For instance, instead of simply requesting name, we can be more specific and ask for country name. We also attempt to control not only the structure of the embeddings, but also the specific pieces of values that are included. However, it's important to keep in mind that GPT is a language model, not a database engine. In other words, it generates text based on what it has learned from its training data. While we may have some limited influence on the values we receive, it's important to note that these requests are often ineffective, as seen in the current example. In reality, we shouldn't even expect a language model to understand that, for example, the string 37 represents $37 million when it's used to indicate a country's GDP. Sometimes we receive values that contain dollar signs or words like million, as they appeared in the original training documents. These situations require logic that can be added with the help of CRANQ to handle them appropriately. In this brief example, we use the pattern we have seen earlier and perform some sample processing on the results. You may notice that we have added a request to the prepared prompt to enclose the values in quotes. This is to prevent the JSON structure from being ruined by values that contain commas. The returned values may not conform to a numeric format and may have some traps. To address this issue, we can extend the OpenAI node to perform some data cleaning. The specific functionality required to filter responses will depend on the task at hand. For our demo example, I have implemented a node that takes the two numeric fields and applies a somewhat wider strategy than normal number parsing. It recognizes frequent currency names or symbols and removes them. It also understands what a million or thousand means, or just their one-letter abbreviations, and can handle digit group separators that OpenAI insists on returning. As a general practice in IT, it is recommended to apply a retry policy on API calls themselves, as issues can arise due to many factors. In the case of large language models, limited computing capacity is a particular challenge. We experience a variety of error messages these days. Even if a call technically succeeds, the results may not be satisfactory, and a more stochastic approach may be necessary. This could involve replacing the call or combining results from multiple calls. The exact criteria for repeating queries is task-dependent, and a one-size-fits-all strategy is not feasible. Therefore, a framework is necessary to define the logic for these criteria. In the following examples, we will demonstrate some of these cases. You may want to use CRANQ to apply your custom logic. The most simple case is when you cannot interpret a response from an otherwise successful call. Remember, even for the most perfect prompts, there is no guarantee that the content will be generated according to your requirements. Furthermore, often you will combine your prepared prompt with a user input that you have no control on. It can easily happen that the response is beyond the abilities of your parser node. Another scenario is when you require results from multiple responses. Language models can provide useful data, insights, or opinions, but each response is based on a specific completion. The model has been trained on millions of documents, and the data in them is as inconsistent as what you may find while browsing the internet. Although OpenAI has made strides in balancing these inconsistencies, Differing opinions or data may still arise, even for the same question. Unless we force the model to stick with one option every time, that we definitely don't want to, there may be variations in the results. For example, the model may evaluate the sentiment score of a given text differently or provide different nutrient information for bakery goods. Depending on the task, you may need to apply averaging or exclude outliers or use a 2 of 3 strategy to obtain reliable results. Another scenario arises when each API call provides useful insights, but a comprehensive result is unlikely from a single response. As an example, I created a prompt that intentionally contained various mistakes and asked OpenAI to check it for grammar, style, typos, and advise against inadvertently inappropriate content such as racism or sexism. Although OpenAI could spot virtually every problem, no single response was comprehensive enough to cover all issues, even when explicitly asked to address all problems at once. Each response reported only one or some of the problems, and they were mostly not overlapping. Only by combining the responses could all issues be covered. It is important to note that there is no one-size-fits-all approach. For example, determining whether a warning applies to the same problem or not is task-dependent. Therefore, you need a framework that allows you to add your specific logic to make custom decisions based on the task at hand.